Hi, everyone. Thank you so much for joining us today. Happy to have you here again for another great Magnet Virtual Summit session. Today is going to be no different than the others. It's going to be chock full of just amazing learnings. My name's Jessica Hyde. I'm Director of Forensics here at Magnet Forensics, and I'm stoked to be able to welcome you to our presentation. Today, I'm joined by Aaron Sparling, an officer at Portland Police Bureau. Aaron's going to be presenting Emoting over Emotet and Maldoc. A cool name. This is going to be an incredible session. I've seen the deck, just tons of great CLI work that's going to help you analyze malware. We encourage you to ask questions. You can do so in either the GoToWebinar interface or if you're a member of the Digital Forensics Discord server, we're going to be opening up a channel for this talk just as we have been with all of our Magnet Virtual Summit industry lectures. So you can have live discussion there. We actually have Tara Melton and Pooja Bala in the Discord ready to help you if you have any questions and to pin things for Aaron. After that session, we'll both jump over there. This recording will be available in about 3 to 5 days, and Aaron will also be sharing his slides. So we'll send those resources out to everyone who's registered. And as a reminder, we also have the Magnet Scavenger Hunt running through this and all other sessions. There's going to be a fun question, so be sure to pay attention so you can get that answer. The question's already been posted. The link for the Scavenger Hunt as well as the Discord are also in the chat. And with that, over to Aaron.
Well, thank you, Jessica. Good morning, everyone. She introduced me, so I'll skip this slide. So I guess real brief, we'll just discuss what we're going to cover. Yes?
Aaron, your slides are not forwarding.
They're not. Interesting. Okay. Let's see what's happening. There's the play button. How about now?
Nope.
Okay.
We are still seeing your title slide. There we go. Congratulations.
Okay. Perfect. All right. For some reason, the play button was stuck. All right, great. Well, we got through our first technical difficulty without any total failures. All right, so what we're going to cover, we're going to talk a little bit briefly about what Emotet is, what it does, and some of its TTPs. And then before we get into the analysis portion, which is the bulk of this presentation, we're going to talk about what makes up some different parts of different documents. So we're going to talk about PDFs, OLE format documents, Microsoft documents, and RTF, rich text format documents. You'll see some examples of some malicious payloads. So there'll be some examples for how to deobfuscate and analyze shellcode, as well as JavaScript and BBS script, as well as locating downloaders and droppers. There'll be hopefully some really fun and cool analysis tools that you'll be introduced to, or maybe that you're already using, and maybe you'll pick up a new trick on that, and I'll walk through those. But like I said, the bulk of this slide deck, which is a pretty aggressive slide deck, is going to be a lot of screenshots of some analysis walkthroughs. So we'll be doing some static analysis of malicious documents. So Emotet. Let's take a look at Emotet's dating profile. It's roughly been around since 2014. Started out as a banking Trojan. It now targets. It's definitely matured, and it targets all kinds of industries, such as finance, government, energy, shipping, utilities, and then fill in the blank. Because now that it's evolved as a malware as a service, it can be used for just about anything. Probably one of the two most common that I have seen during my investigations that Emotet likes to distribute is the TrickBot and the Zeus Panda. The most recent investigation I did was a Zeus Panda intrusion case that was deployed. So we'll talk a little bit about its functionality. It most commonly distributes other malware families as in the form of a downloader or a dropper. You're going to see examples of both of those when we get into the analysis portion. It can be used also as a credential stealer, so it can grab credentials from web browsers or email clients. One of the things that makes it also a little more dangerous is it can leverage legitimate software to aid in its credential harvesting, sort of this whole living off the land attack framework that we're seeing. It's also matured to the point where it's using more sophisticated packers and obfuscation for to avoid analysis and to trick up and just frustrate the examiner or analyst that's doing the analysis. Two ways that we're seeing that is through polymorphic packers and then also encrypting the IAT, the import address table. But the big thing that we're going to cover over the bulk of this presentation is how Emotet leverages documents as its delivery mechanism. And the three that we're going to look at are PDFs and Office documents in the form of OLE and RTF documents. It also, so some of its functionality, unlike most malware out there, it likes to use process injection, and it picks on explorer.exe. You will, I think it's the last walkthrough that we do, we'll see an example of that. It likes to establish persistence, and there's got to be some sort of communication via C2, so we'll look at how to analyze some of that today as well, and that communication can or cannot be encrypted. Attack campaigns range from like really, really basic or rudimentary to well-crafted attacks. The ones that we've sort of picked out today for doing document analysis kind of fall somewhere in the middle. This is just a slide that I pulled down from the US CERT website that shows the sort of the attack matrix of Emotet. And it's just a really good slide that illustrates the deployment of it and the documents getting into the environment and pivoting laterally, and then eventually either getting a hold of like the global address book or credentials. This is another document that came out of a report that was published last year from Bromium. Really good report. I encourage everyone to go and download it if you're more interested in reading about it. But it talks, the thing I like about this diagram is it covers the whole ecosystem in terms of the organized crime aspect of it, and how all the way to include like the cash out mules and how the whole ecosystem works within the environment, not just the attack matrix of the malware itself. So before we jump into the analysis, we need to spend a couple minutes just talking about what makes up these documents so that we can kind of understand what the structure is of each document before we start to analyze it. And the first one we're going to talk about is PDFs. And yes, believe it or not, PDFs are still being exploited and still being used. Actually, probably one I've done recently, which was a ransomware case, was actually a really well-crafted attack that involved a PDF. That was actually really well done. So PDFs, portable document format. What's really interesting about these is they can contain text and images and scripts, but they can also contain action scripts like embedded Flash. So, you know, early mid 2000s, it seems like we're always hearing about Flash exploits. Malware likes to use PDFs as both either a downloader or a dropper. So we're going to see examples of that through the analysis as well. And then attackers are able to interact with remote sites, deploy embedded files, and run local programs. So they can, gives them a lot of flexibility by using a PDF. And then probably the most common thing that I see is embedded shellcode and deploying shellcode. And we'll definitely see some examples of that. So PDFs are made up of a collection of elements. These elements describe the file structure of the actual PDF. And they tend to have indirect, we'll get into that in a minute, but there's a header that contains the info, and then it's object oriented, so you're going to see the different objects that make up the PDF, and these will be made up of, you know, graphics or text, but usually what we're looking for is some sort of JavaScript or malicious JavaScript that we can then analyze. The cross-reference tables and the trailer and stuff just make up some of the body. If you're more interested, you can look at the slides later. So I started to touch on this, but PDFs use indirect objecting to refer to other objects within the PDF. So if you're really new to it and you've never really done it, it can seem a little circuitous how one object will point to another object that might point back to an object before it, and you have to kind of, it can be kind of fun actually to manually traverse through these different objects to actually get to the data that you're looking for. The first number that you're going to see is the object number, and the second number is going to be is a generation number, which will point back to another object or reference an object. But the big thing that we're looking for is the AA, or this automatic action, where the malware authors will like to leverage that functionality within the PDF, which will automatically deploy their payload as soon as the victim interacts or clicks on the PDF. And the other big thing that we'll be focusing on is looking at concealed JavaScript, which is inside of a stream object within a PDF. So some of the tools that we'll be looking at as we go through the analysis portion is PDF ID. PDF parser is actually a Python script from DDA Stevens. He has a whole host of Python scripts and tools that he has written for doing malicious document analysis. And because my slides that you'll see have a lot of flags or conditions set, I went ahead and threw some of the flags and conditions in here for you guys to go back and review later if you want. PEPDF is another tool that is it's a Python framework that'll allow you to drop into that framework and interact with the document. Really powerful, has the ability to also deobfuscate and analyze JavaScript using SpiderMonkey, which is really powerful and can be really useful in your investigations. Office documents. So the big thing about Office documents, especially with the OLI format documents, is the malware authors want to leverage the macros, the ability to interact with the macros inside the document to deploy and activate their payloads. So what's great about Office documents is people use them pretty much on the daily for legitimate purposes. So they're coming in and out as email attachments, by the hundreds, depending on how large your environment is. And so it's not uncommon to see them. So it's really easy for them to pass those through to the everyday user. And unbeknownst to them, they've launched an Office document with a malicious macro. The other thing that they'll leverage with the macros is they'll utilize the Visual Basic for Application Language, or VBA. So they'll have a malicious VBA script that's embedded into the macro that then will either go out and drop the malicious executable or call out to a compromised PC or compromised computer or a hosted C2 server and actually bring the payload back down onto the victim system into the environment. One of the other things that makes VBA so attractive is that it can interact with the system and it's incredibly powerful, meaning that there's a lot of scripting capabilities to the author that they can leverage again, kind of using that whole living off the land philosophy, they can leverage a lot of the stock features within the system to deploy their malware. Malicious macros usually run automatically. So again, kind of like the open action or automatic action in PDFs. Once the user opens the malicious document, then you'll see that instantly things start to happen in the background, maybe unbeknownst to the victim. When we get to the last case, when we do RTF, you're going to see a sample walkthrough of a short section of some dynamic analysis where you'll actually see this in real time, how this works. The other thing that is macros are able to download and save files, kind of talked about that a little bit, as well as execute arbitrary programs. We talked about that a little bit as well, but that's just leveraging some of the software that's already on the system to do some of its bidding. And again, malware authors love to obfuscate their malicious script within the macros using tons of junk code. And junk code is just adding code that means absolutely nothing so that it's very daunting or overwhelming to the analyst, can either confuse the analyst or frustrate the analyst. They'll use, and you'll see examples of this, they'll use really weird strings for defining variables. A lot of just code in the middle of this section just means absolutely nothing and has nothing to do with it. And so when you first start looking at this, it can be incredibly frustrating or confusing to kind of figure out, okay, what is legitimate, what is not, and then clear all that out. So the contents that are embedded as a string, the macros don't support actually executing that script. So you have to, it'll interact with the system. So we're looking for the VBA script to execute. And we'll look for, JavaScript with like an eval command that's going to evaluate a function that's going to run something. And you'll see examples of this as we go through. So again, I talked kind of about this already, but there's two formats that these OLE formats. There's the sort of legacy, which is this structured storage system, and looks when you look at it, it reminds me very similar to a file system where it uses storage and streams, which is much like folders and files. And the modern day is the Open Office XML, which uses multiple files and their contents are contained in a zip file structure. And we'll see examples of that as well. The tools that we'll be demonstrating today for the analysis portion are kind of broken up into a couple sections. So there's analyzing the document itself to get some of the metadata structure, which can be very useful for, say, like cyber threat intelligence, getting an idea of maybe what your attacker is trying to do. You can do that real quick on the front end, or just identifying what kind of documents you're dealing with. And we'll have analysis tools like that you'll see, like OLE VBA, MRaptor, and OLEDump are the two probably predominant. And OLEDump is actually a Python script. So I apologize, I should be adding a .py to some of these tools, but they'll make sense when we walk through the analysis portion. But these tools will actually leverage statically the document, and we can manually go through and parse the data. The structure analysis stuff that you see up here, again, is just really to break down the metadata structures. And then another tool on the bottom of the slide, which is ViperMonkey or VMonkey. This is a really neat, powerful framework that interacts with the document and does a lot of decoding for you. Same with this P-code dump. It'll not quite like ViperMonkey, but it will dump some stuff for you as well. There is not an example of that in here. I had to cut some of the slides short, as you'll see, but you'll definitely get a chance to check out ViperMonkey. The other thing I should say about ViperMonkey as well that's really neat is you can also do some malicious script analysis within ViperMonkey, not just by throwing it at a document. So last but not least, we'll talk real briefly about the RTF formatted documents, or the rich text format documents. They're supported by Microsoft or non-Microsoft applications. So thinking like your LibreOffice or your OpenOffice, it allows for files to be embedded. The difference between like an RTF document and an OLE form document is RTF doesn't support macros. So you'll see that when we do some of the initial upfront analysis, when you're looking to see, does this document have macros or not, and why. This next one is really important, and we'll see an example of this when we do the dynamic analysis, is when Microsoft Word opens an RTF document, if there is something embedded, it's going to extract that embedded object to the user's temp directory. So we'll want to keep that in mind when we go through the dynamic analysis portion to see if anything's been dropped into the user's temp directory. Again, just like all the other documents, shellcode can be embedded and activated from within the RTF file, and we'll see that. And then as we're doing the analysis, the static analysis of an RTF document, one of the control words that I'm looking for is the obj data control word, because that will typically point to an embedded object, and you'll see examples of that as well. There's actually three tools that we're going to use for the analysis. There's the RTF dump, which is used to actually dump sections, and then RTF obj, which locates and extracts embedded objects for us, or RTF dump.py, again, it's a Python script from DDA Stevens, will manually go through and pull stuff out. And then the other one is going to be RTF scan, which is actually a Windows binary for doing analysis, but I'm actually running on this Linux VM that you're going to see. So I'll explain the differences when we get there. So now for the fun stuff, the analysis walkthrough. So we're going to look at roughly 6 different documents, 2 from each category, and we're going to look at them all statically except for the last one. The last one I'm going to show you a really neat little Python script that will attach to WinDebug and do some dynamic analysis. And then we'll have a little bonus section at the end. So starting with Microsoft Word documents in the OLE file format, the first thing, and I do apologize if some of these screenshots are a little fuzzy. I try not to zoom in on them too much. But imagine that this maldoc1 .doc is in its own directory. And thank you. And first thing I'm gonna do is just run the file command, the Linux file command against it to see what kind of document I'm dealing with. And it just real quickly will give me some pretty quick metadata about the document. And I can use a couple other tools within my toolbox that will give me some of that same information, right? So here you can see I'm using OLEID against this same document. And in fact, it is a Microsoft Word document. I'm looking to see if there's any VBA macros. It says true that there is. So I'm starting to get a little bit of information about my document before I dive right into the analysis. Two other tools that you can use for metadata is the trusted EXIF tool. And you can see here with an EXIF tool in the highlighted red, we can see that, it was last modified by a Windows 7 home system. We get created and modified dates. So that kind of gives us maybe some date and times that we can go off of to see, what was in vogue during that time for malicious payloads, or what kind of TTPs were the threat actors using, or the malicious malware authors using at the time. So it gives us some intel to work on. And then over here on the right side is the only meta tool, running it against the same document statically. You can see the same thing. The author is admin, the Win7 home, and we get the same created and modified dates and times. This is just another OLE times is just another way to look at some of the metadata structures within that document statically. So one of the first things I'll do is I'll drop the document into vMonkey, and vMonkey is an interactive framework that will go through and it'll parse or attempt to parse. Sometimes it's successful, sometimes it's not, like all of our tools, any VB script. So it's looking for malicious, or not just any VB script in general. So you can see here I've kicked off vMonkey against the document, and it's starting to run through and process the document. And instantly I'm starting to see some stuff that I might want to make note of and take a look at. So here I'm seeing reference to a shell environment, to the temp directory, and an executable named 1.exe, which is not normal. And it continues to run through again as you read through the output of your ViperMonkey or vMonkey. You can see the shell command to the user's admin app data local temp for 1.exe. And then the red box in the top right would be actually at the bottom of the readout. And here you can see it's giving you some of the, it's basically doing some heuristics or some parsing for you. And again, we're starting to see reference to this user's admin app data local temp with this 1.exe executable that's being dropped, or maybe being dropped. And this is that same picture just blown up. So that you get an idea of what it's looking for, and it gives you something to instantly pivot on, right? So if you didn't know where to maybe go look on the machine, now you might know where to go look. So we've run it through some automation. So now we want to start manually parsing this. So we're going to use the oledump.py running against this same malicious document. And here we see a reference in stream 8 to a macro, and with a decent file size. And then stream 14 we see with the capital O is an object. So now I want to go through and I want to manually interrogate both of these streams. So the first thing I'm going to do is take a look at stream 8. And so by using the -s and saying, hey, I want to look at stream 8, it basically just gives me a hex and an ASCII output to standard out. And as I start to scroll through this output, I can see again reference to this temp directory with this 1.exe. If we were to start to look through this and tear this apart, we would see some interesting strings inside this, like put in clipboard, and there's a few other things in here that we would notice. And then as you continue to scroll down farther through the output, we see reference to the user's home directory. Again, we're seeing the exact same output that we were seeing before from vMonkey. So this is a great way to be like, okay, I got two tools that are kind of showing me the same thing. So now I'm like, hey, okay, so I saw some interesting strings. I want to see a little bit more what's going on. So taking a look at string 14, using the dash capital S for strings, it'll parse strings. And not only am I seeing a reference to 1.exe, but you'll notice like the fourth line down, you're seeing portions of what's probably a PE header, right? So we're seeing like the resource section, the data section, the text section, and the R data section. So those are all sections of a PE header. So you start to think, well, maybe I've got an embedded executable in this document. And as we move farther down through this output, we start to see some potentially risky API calls associated with that section within that document. So we're seeing stuff that leverages the registry. We're seeing like create mutexes, and we know that mutexes aren't necessarily bad, but we also know that malware authors will use mutexes to make sure they're not reinfecting the same machine over and over again. And then, so if you work through this strings output, you would see a lot of interesting API calls and stuff that may or may not be malicious, but they're definitely stuff that you might want to look at for how this is functioning or interacting. So because we felt reasonably sure that maybe we saw what looked like signs of a PE header, again, looking at that string 14, I'm taking the output and I'm passing it, I'm piping it to pecheck.py, which is another one of DDA Stevens' tools, which actually will say, hey, if there's a PE header in here, I'm going to look at it and start to process it. And we, in fact, see that this is happening, right? So we, I don't know if that's working, but you will see that, I'll see if it works, but we'll see the magic header here, this 4D5A for the MZ header of a PE file. So we're like, okay, we're on to something. And I'm just going to take that same output now with OliDump, and I'm just going to pipe it to less. And then using the search feature within less, I'm going to start to manually look through my hex output. And again, on the screenshot on the left, we see reference to the 4D5A. Hopefully it's a little bit highlighted with the 4D. And then these two E's, each one of these followed by the these reference bytes are for the different sections of the PE header. That's our resource text, our data, and data headers. And we could parse those manually if we wanted. And then we scroll down just a little bit farther in our output, and we see the 4D5A, and we see the reference to the MZ header. And again, this is just showing a close-up of where we were seeing the directory path written to. So again, we can interrogate that. So we feel like we've reasonably identified maybe that there's an embedded malicious executable within this document. We can now leverage OliDump to try to carve for that malicious binary. So if you look at the second line from the top, you'll see that again we're interrogating stream 14, which was that object stream, using the dash capital C, and then going back. If I was to go back, you would see using these hex offsets here and here. We're actually carving between these two hex offsets with the dash D, saying I'm dumping that carved section, and then I'm redirecting that out to a file that I'm calling 1.exe. So that's all we're doing statically, and we haven't detonated or deployed or interacted dynamically with the document at all. Written out the section, and now I'm using a tool called PE scan to scan that 1.exe, and we can start to see that, yep, we're seeing signs that, yes, we are dealing with something that looks like a functioning PE file. Another tool that we can throw that recently carved binary out is with the malware overview. Jessica and I talked about this tool in our presentation on Monday, but this is a great tool that if you have your own API keys for different virus vendors like VirusTotal or Hybrid Analysis or Polyswarm, you can go into the configuration file, load your API keys, and then you can run malware overview against your binaries with different conditions and flags and start to interrogate the PE file. So here I've just highlighted the MD5 hash. Again, I'm looking at the entropy of the PE file headers, and it does an automatic, because it's leveraging my API key for virus total. I get a virus total hit on it of 51 out of 73, which is pretty high. And then also it does some checks for packers, and it looks like, in fact, it is possibly packed. So again, with this screenshot, I've just added a bunch of different variables to leverage a bunch of the different virus tools and engines that are built into this Python framework to take a look at this particular binary. And if we look down at the bottom, we start to see that, hey, we're dealing with probably a Trojan downloader of some kind, and it gives us some indication of what we'd want to go out and start doing our research CTI-wise to see what we're dealing with. So here, this is just me taking that same approach, but pumping it out to less, and so that you can. I just threw this in there as sort of like a community service announcement. Sometimes it's good to go into less first, look at your output before you start kicking it to standard out. It can save you some time. So now with that same document using OLE VBA, we're asking the tool to it goes through and it starts to it goes through and it will do this similar to what vMonkey does, but not quite as in depth. It'll go through and identify some indicators and give the analyst some indicators up front. And again, we see that there's this 1.exe IOC. We see some suspicious VB, possibly VB script. We see a suspicious shell command. We see a suspicious environment. So there's a lot of indicators that you can give to the analyst real quick to start working on this document. So you can use the --d obfuscation and --d code flags with inside of OLE VBA in the event that there's any sort of obfuscation or if you need to decode anything. And in fact, when we do that, we get an extra string that basically just shows that the 1.exe may reside in the temp directory. So it gives us one more place to go look. Another tool that we can use on this document is Office Malscan. This is a Windows executable, but I'm running it in Wine with inside the Linux environment. So that's how I'm able to do this. And with this tool, you can use the scan or the info kind of plugin against your document. And in this case, I use both of those. It's pretty verbose, and it will actually go through and it'll actually dump a section into your current working directory and dump it as a bin file. So if it finds that section that we manually carved, this will go through, identifies it, and pulls it out as a bin file. So we see here that it actually dropped this bin file that's roughly the same size, or it's actually the exact same size as what we manually carved. So if you look 2 lines above the red highlighted box, we'll see the exact same file size of 1.exe, which is what we manually carved like 6 slides earlier. And then this is a tool that will go through and do it for you automatically, but another way to check your work. And just me pointing that out. Here I've run the MD5 sum against the files in the directory to see, hey, not only is the file size the same, but are the hashes the same? And they are. So it's another way for me to check my tool and make sure that what I'm getting is the same of what I saw when I did it manually. And again, just one more way to interrogate that embedded executable is we can jump into a tool called PE frame and start to look at the malicious binary and look for any other indicators that we might need. So in this case, again, we get the 51 out of 73 from virus total. We get the compiled date and time of it, 2017. So we can look and say, hey, what was in vogue in 2017 around November? We can look at some of the features like mutexes and anti-debugging and packers and start to go through and interrogate this actual PE file. So this is just all the different commands that you can run within this PE frame framework. And here I'm just using a couple of them just to real quickly analyze this particular PE file. So I'm looking for like in the right side screenshot, I'm just going to start looking at like some of its behavior, right? So I'm looking for mutexes, and it says that it interacts with the registry, and maybe there's some file operations that are being done. So those are some things as the analyst that I want to keep in mind as I start to continue to interrogate this particular binary that was embedded in this malicious document. So this is, again, using PE frame to check the behavior of it, check the hashes, any kind of info that we want that might give us, stuff that we can use. Again, it's real quick for virus total. If we wanted to look at, strings inside of it, that we can look for file strings and URLs and things like that. So it gives us, and you can see examples of all this down here. So when we run the file strings, we see the 1.exe, we see the advapi 32 DLL for interacting with the registry, a shell 32 DLL. So some DLLs where you're like, these are kind of interesting. And then the URL schemas, there's nothing there that's overly suspicious or alerting. We can look at some of the macros as well as looking at just real basic analysis. So that was document number 1, where we had an embedded executable. Now we'll move to document number 2, which is going to deal with shellcode. So going through, you're going to start to see there's a theme. There's kind of this recipe of how I approach this analysis. But again, I'm going to take this document, throw it into a tool called MRaptor, and MRaptor is going to tell me, one, it'll tell you, are you dealing with a document that has macros or not, which is great because you might have a whole directory full of documents and you want to quickly triage them. Imagine you have a directory with 50, 60 potentially malicious documents in it. Using the MRaptor tool will rapidly goes through these documents and will tell you, yep, you're dealing with an RTF document or dealing with an OLE document, and then you know exactly how to pivot and what tools to use from there. So here we're definitely dealing with an OLE document. It says it's suspicious because it has an auto open and probably a shell function. So we're like, okay, let's see what's going on with this thing. So again, we'll quickly just kind of breeze through some of the metadata stuff, but looking at what makes up this document, am I in fact dealing with a Microsoft Office document, and using the same tools that we used before for getting the metadata structure for that analysis. No different. This is all the same thing that we saw before. And now we start to manually go through and take a look at this particular document. And here we're using OLE VBA. And again, we're going to use the --d code and the deobfuscation plugins within the tool, ViperMonkey. And we're also going to run ViperMonkey against this tool. And it goes through and starts to parse and looks for any VBA code. And sure enough, it finds some. No surprising. And as we start to go through it, we start to see something. We see a shell function, and we start to see a bunch of just random numbers. And if you've never dealt with shellcode before, you might not recognize this as being possibly or potentially shellcode. Shellcode can be formatted in a couple different ways, and this is one way that shellcode can be formatted. So when I see this, I instantly start to think shellcode. So looking at the bottom of the output of vmonkey, again, it will give the analyst kind of like a quick little summary. And inside that summary, I see that this same block of characters that represents or looks very similar to shellcode that's really close to a shell function. So I scroll back up through my output. I'm going to highlight that section. And then I'm just going to real quick, I'm just going to make an empty file, call it shellcode.bin. And then I'm going to jump into that and I'm going to paste, basically all I'm doing is pasting that into that shellcode.bin file that I created and doing a sanity check to make sure that it all copied over. Then I can take that bin file that I created here and I can use a Python script, the sc_distorm, which leverages the distorm framework, distorm 3, if you're familiar with like volatility and you drop into malfind, and or not malfind, but volshell, and you want to manually take apart sections and do some disassembly work. It uses the exact same framework as you're seeing here. So pointing the shellcode_distorm script at this sc.bin file, we can see what reasonably looks like assembly code So we're thinking, okay, we're probably dealing with some shellcode because we see what reasonably looks like legit assembly because we see references to different registers on the stack, right? So like the base pointer and we won't get into that, but we see a bunch of references to assembly. So we're like, okay, this is probably legit shellcode. And now I'm like, okay, well, I'm going to throw it into SC debug, which does, if you've never used SC debug, again, it's a Windows binary, but I'm running it in the Linux environment, but it'll allow you to do, it does a little bit of emulation. And I'll show you in another example how you can actually leverage it even more in depth in here. But it's stepping through the shellcode, and you can see in the highlighted box that, again, it's showing some assembly that looks like a JIT assembly, right? So we're seeing a reference to the base pointer on the stack and a couple of different registers. So maybe we're dealing with some sort of function prologue or for code injection. So that was kind of quick, I know, but that's two different examples of doing document analysis for Word documents that are OLE formatted. So again, just to summarize the two that we looked at one that had an embedded executable, and then the other one which had shellcode. And obviously you would want to interrogate this shellcode more, but now you're starting to get the idea of how to get the information that you need real quick. So PDFs, so yep, they're still used, they're still active out in the wild, and they're still a lot of fun to analyze. So again, I just always want to get the metadata stuff real quick out of the way, and that's what I'm doing here with the PDF info. The big thing I'm looking at is the PDF version 1.1, because then I can look up and say, okay, what were the common exploits for that particular version for PDFs of 1.1. And now I'm going to start to statically analyze this particular PDF, which is this return invoice.pdf. It seems like they're always coming in as like invoice or payment or something that will catch the attention that the user will click on. So here we have a return invoice.pdf. Again, talking about objects and referencing and indirect objects. So here we'll see that we've got an action in object 7, which might be important. We see that JavaScript is referenced to object 7. We see an open action reference to object 1. And as we start to go through this, you're going to see how they're going to cross-reference each other. So the first one, because we had JavaScript, and we know that sometimes our malware authors like to write malicious JavaScript and embed it to do their evil bidding, we're going to first take a look at object 7. So just running the PDF parser.py Python script and saying, hey, just show me object 7. I see this, I see a reference to JavaScript and then a big jumble block of just nothing. And most people are instantly going, ooh, that's probably base 64. And we know that malware authors like to use base 64 for their encoding. So we'll take this one step further. And so instead of just kicking it to standard out, I'm going to pipe it to another one of DDA Stevens' tools, this base64 dump.py. This goes through and analyzes the output. And it says, hey, for object number 2, I see what reasonably might be some base64 encoded strings. Does a quick little kind of decoding, and I see a var and to a weird string, so probably a variable to an obfuscated string. So I'm like, hey, I want to see what's going on with this section 2. So here I take it one step further. So I do the PDF parser and pipe it to base 64. And I say, hey, I want to look at stream 2. And now I can start to analyze this particular stream output. So we'll just continue to drill down through stream 2. And again, adding, and these will be on the slides, but adding more conditions to the tools, I can start to slowly peel back the layers. And again, I'm starting to see these what are assigned variables, which is probably going to be some sort of base 64 encoded JavaScript. And we can take this output and clean it up by using the -t and the UTF-8 command. It starts to clean this up, and it looks more and more like, yep, we're dealing with some sort of obfuscated JavaScript. you could, and some of this is going to be junk code, and some of this you have to go through and manually decode yourself, which is outside the scope of this presentation, but I'll talk about some of it. What I'll do next is write this output to a file, which we've done here, which, oops, wrong way, which we've labeled to stream7.js, and then throw it into your text editor of choice. In this case, it's going to be Sublime. And I can start to maybe see references to, if we start to concatenate some of these strings and variables together, you might see references to like WScript, and which you would if you started to do the malicious code analysis on this. And so you could actually start figuring out what these variables are, what they do, and continue your analysis from here. So another tool that I like to use is ppdf, which is a Python framework. You can use it interactively, or you can use it just on the command line. I prefer to use it interactively, and this gives you an example of when you do drop in interactively, all of the different plugins that you can use. And again, you can use it to do JavaScript analysis because it has SpiderMonkey. It calls SpiderMonkey to do some of your JavaScript analysis, which can be really useful. So here we're using the PEPDF against the same PDF in interactive mode, and down in the bottom, it gives me the exact same output that I saw before, except here I see that the file is not found on VirusTotal, so that's kind of good to know. But I'm still seeing the same objects, object 7 and 1, that have references to an open action and to JavaScript. So looking at object 7, again, I see what looks like base 64 encoding. I want to decode that file, so I say decode that file, and I'm going to call it raw_7.txt, and I want to decode it using the base 64 capabilities with inside ppdf, and it gives me the output that we saw before. So again, using two tools to kind of say, yep, this is what I'm dealing with, and then I'm going to write that out to a raw_7.js. And so we can see here that our raw_7.js and our s7.js are roughly the same size. So we've probably there might be a few characters that just didn't parse the same, but we're probably dealing with the same piece of JavaScript. So now we've found the malicious JavaScript that's embedded into that PDF, and we can do the malicious code analysis on that JavaScript and continue to take it one step further. So we have one more PDF before we get to RTF. So again, we're dealing with like a payroll kind of, something to catch the user's attention. In this case, it's payroll.pdf. And I see references to JavaScript again, as well as an open action inside of objects 1, 3, and 5. So those are the ones I'm going to want to interrogate. And if you were just to throw this into payroll PDF without asking it to look at any objects, it's going to spit all of them out to standard out. And so I wanted to show a brief little example of what that might look like. So you'd have to manually scroll through and start to reference them back and forth. But we can see here that, object 5 is referencing object 9 that potentially has JavaScript, and we can continue to work through the objects that way. So because we knew that 5 was referencing 9 and 9 might have JavaScript, we want to take a look at that. So looking at object 5, lo and behold, yep, it does reference object 9 that potentially has JavaScript. And so now we're like, okay, well, let's pivot and look at object 9, and we see object 9 contains a stream. We're like, oh, okay, that's interesting. So looking at object 9, we're like, I want to look at the stream, and we see this variable titled payload, and then we see this incredibly long section of what looks like, again, shellcode that's just formatted differently than the shellcode that we saw before. So I'm like, oh, okay, well, I've got probably a payload of shellcode here. Let's take a look at that. So I want to look at the raw output of that. It kind of cleans it up a little bit with the -w. And again, we're seeing, if you look towards the bottom below the variable payload, you see references to a no-op, which is no-ops are really common with shellcode. So again, we're starting to think, okay, we're probably dealing with shellcode. So write this out the same way we did before, except this time we write it out to object9.sc. running the SC distorm against it, and I see what looks like a legitimate assembly, because we're definitely seeing the stack pointer being referenced to the base pointer, and so we're seeing what looks like legitimate assembly code. And you're like, well, I kind of want to know what that is doing. What's really neat about this Python script is not only does it go through and give the analyst the standard output in assembly, if in fact it is assembly, it'll also write that to a shellcode.bin, which is what you're seeing here. So it writes that output to a bin file. And now I can say, hey, I'm going to use my scdebug tool to take a look at that shellcode.bin. And it runs through and we see some API calls. So we see load library, we see get file size, and we're starting to think, okay, seems pretty legit. Let's take that one step further. So using the scdebug against that shellcode.bin that we created from the sc_distorm tool, I can use the fopen condition and point it back to the original PDF with a couple other flags to say, hey, I want you to actually pull this PDF in, and I want you to basically, we're doing some emulation and interaction without really deploying anything. And what you're going to see is a reference to a create process with this foo.exe, and then we see a shell execute with a bar.pdf. And then it will drop it into your working directory, and we can do some analysis of these two files that were extracted using that process. So when we run the file command against our directory now, we see that we have what looks like a Windows PE file or an executable and a newly generated PDF document. And so I want to look at that first one. I'm kind of a neat freak, so I clean up my directory a little bit. So I jump into PE frame and in the interactive session, and I want to look at that file that was potentially that scdebug pulled from the process. And we start to see some anti-debugger and packer stuff that's maybe being used with this particular binary. We're seeing some anti-debugging stuff with terminate process. And we can just slowly start to filter through this and do PE file analysis now and see what are we dealing with. Again, just like before, I've got legitimate PE header sections that I can look at if I want. And more importantly, I can take a look at some of the API calls and say, hey, are there any risky API calls that are more commonly associated with malware? And in this case, when you look at this, you see a whole host of API calls that look really reminiscent to code injection, like virtual alloc, load library, get process address. This whole thing is a recipe for code injection. And then these are obvious DLs that it would want to function with, so that makes sense there. And we can continue to look even further into this particular binary that we extracted using the PE tool as well. So it will tell you by using PEID what type of packer we're dealing with or potentially dealing with. You'd obviously want to go and manually check that. And if there's any suspicious sections of entropy, which are usually commonly associated with packing. So again,
hey, Aaron, just as you jump into your RTF, I just want to make sure everybody knows that Aaron does have a bit more material to go through. So we're going to let today's session run long, but any of you who have to drop at noon totally understand, and we'll be sure to send out a link with the recording in 3 to 5 days. Is that cool with you, Aaron?
Oh, totally cool.
Awesome. Thanks, everyone.
Okay, so I'll get cruising then. So we have 2 RTF examples, and they should go pretty smoothly. So same thing, just similar as to all the other documents before that. I'm gonna see what kind of document I'm dealing with, analyze the metadata, make sure in fact that yep, I'm actually dealing with an RTF document, so I know what tools I want to use for the static analysis. And then I'm looking for some creation stuff. Here we're using the rtf.obj tool, and it shows me that object 0 maybe has something that's embedded, or section 0. So I'm like, okay, I want to go look at that. So if we look halfway down the screen by invoking the -s flag and saying, yep, interrogate 0, it's the only one that I've got. Not only will it take a look at it, but it'll take whatever that object is that's of interest, and it will drop it to a bin file. So now I have this dropped object as a bin file. Again, I'm a neat freak, so you'll see that I kind of clean that up a little bit and just truncate it or turn it into 2019.bin. And I'll real quickly use something like XXD to look at it and be like, there's not a whole lot here. But as I start to scroll down through it, I see a reference to PowerShell, and then again, what looks like base 64. It's a pretty small section. I'm like, that's kind of interesting. It's not very long. So I continue down through my XXD output, and I see another section which looks like, hey, this might be also base 64. We will come back to this, I promise. So now I'm like, all right, I want to look at this document a little bit more in depth. So I'm going to use the RTF dump tool from DDA Stevens, and I'm going to look at these. I'm going to look at the different objects inside this RTF document, and I'm looking at nesting levels, and I can talk more about this offline, but as to why I'm doing it. And I'm also looking for references to objects. Remember, I talked earlier in one of the early slides about the obj data, and you can see on the third one down, I see an obj data reference. So it's like, that's kind of interesting. So objects 5, 22, and 29 are the ones that I'm probably going to want to interrogate first. So taking a look at 5, the output, not generally useful, but this is kind of step 1. And I'm like, all right, I want to start looking at that a little bit more in depth. So I want to look at some of the raw output a little bit and try to clean it up. And as we start to clean this up and scroll down through it, I start to see strings that look like they're in another language to me, a language that I clearly don't speak. But I'm like, okay, this is kind of interesting. So maybe I'm onto something, or maybe I'm not. I don't know. So I'm like, I'll come back to that. So now I go to stream 29, and I do that exact same process and start to look through it. And I see what looks like interesting blocks or sections that look vaguely familiar to when we noticed that we had sections of the base 64 that were associated to the PowerShell. So I'm still inside stream 29, and again, using the -H, I can kind of clean this up, and it'll start to break. It will show my strings in a more user-friendly or readable format. And so again, that's using the -H. And here again, I see the reference to PowerShell.exe and what looks like base 64 encoded PowerShell. You'll notice that the yellow blocks, I'm making note, I'll write down my offsets in hex, and it'll make sense in a minute. As I scroll down through the output, I see again what I believe or reasonably believe to be base 64 encoded strings or data. And so again, I make note of my offsets in hex. And I'm going to now go and manually parse those sections. So using, just like we did a couple examples before, using the -C, I'm using the absolute hex offsets to manually carve those sections, using the -D to dump it. And I'm going to dump it to less to do a quick little sanity check. That's really all that is for me, to make sure that I got my hex offsets right. And I recommend that to folks when they're first doing it. I did get my hex offsets right, shocker. And so now I'm going to write that out to a base64.txt. And that's that first section that we identified. And I'm going to rinse and repeat and do that for the second section. So I go through, make sure that my second section of hex is what I believe that I want to write out. I throw it into less for a sanity check, and it is. This is what it looks like when you throw it into less. So you're starting to see like, okay. So I run that second set of offsets, and I concatenate it to my original base64.txt. And now we take a look at what we've got, and we have the entire PowerShell and then the reference to this particular obfuscated section of potentially base 64. Now, normally I won't actually include the PowerShell.exe, but when you're first starting out, I did this as a smart example, because you might want to remember what your base 64 encoding was referencing. So I'll take that file, I'll open it up in a text editor. I'll just grab the base 64 encoded string, throw it into one of Jessica's favorite tools, which is CyberChef. and I'll decode it with the base64 decoder, and we see references to a particular URL. So this is probably a compromised domain that this malware is going to call back to. So now we have some CTI that we can work off of, where before we had this obfuscated sections of base64 that was being leveraged by PowerShell that we needed to concatenate, carve, and put back together. So the last one we should hopefully be able to wrap up in 10 minutes. So again, the last one we're dealing with is an RTF document. Same workflow, going through, making sure that we are, yes, in fact, dealing with an RTF document, grabbing some of our metadata, and instantly throwing it into rtfdump.py. And I'm looking for these nested objects. And again, I'm looking for objects that have large file sizes or interesting references to an obj data, and going through the same process that you saw before, where I start to cull down this data and figure out, okay, what am I dealing with? So as I start to peel this one down, I start to see this weird string.sct file, which is a Windows scripting file. I see a reference to a fake path. If you were to walk through this, it gets a little juvenile. The malware authors were a little juvenile with their naming conventions, as you'll see later. Actually, I highlighted it, but you'll see reference to some VB script, and you'll also see references to a domain, this neeladari.com. So, and then at the very bottom, you'll see reference to a pdf.exe, kind of weird. So I'm like, I want to know more about what's going on here. Again, we'll see a reference to a shell object and some W script. And we see the eval function, which we know is a reference that they use for referencing scripts for evaluating a function. So going and looking at stream 17, doing the exact same thing, except now I start to see that weird long string with the .sct file convention at the end is referencing a temp directory. So I'm like, okay, that's kind of interesting. So much like we did before when we were dumping embedded binaries, I'm doing the same thing, or we'd also did it with JavaScript. Now I'm doing it with what might be possibly a VBS script. So using the different conditions and flags within RTF dump, I'm going to do all the decoding. Instead of spitting it to standard out, I'm going to write this to an evil.vbs, and then I'm just going to real quick do a sanity check cat it, and you can see all the different references that make up this particular script. And we can see some concatenation that's being done halfway down to try to do some obfuscation for creating W script shell. You can see the name of the document, and you can see again reference to this pdf.exe. So using the RTF obj, because we know that that will dump those sections to a bin file for us, we can do the same thing there. So dumping sections 0 and sections 2 in this case, we'll dump this SCT file, and there's an MD5 hash. So I run that MD5 hash into VirusTotal. In this case, this is just a Python script I have that leverages my API that I can call on the command line, where I'll throw my hashes in, and it just quickly will query VirusTotal, and I get a 14 out of 55, but I see maybe I'm dealing with some sort of downloader, which makes sense because we saw reference to what might be a compromised domain. So continuing through the same workflow, looking at these same objects, using the same tools, I did the exact same thing for the other object and go through that same process. So now what I want to do is I want to take that same document and run RTF scan against it. And so using the scan function or scan plugin within RTF scan, I run it, it will dump the object that it finds to a bin file for us, as you see here for further analysis. But it also flags, it says, hey, it looks like maybe we found an OLE document, which is interesting because we're originally dealing with an RTF document. Huh, okay. So now I want to start interrogating both of these bin files. And I do the exact same thing with I treat that dumped bin file that it recognizes possibly an OLE document. Now I had to go back to the OLE document analysis process that we were using before on this embedded section that was dumped. And here, using OLE meta, I can see that I get like an author's name, which is kind of interesting, and I get a creation date and time, which is kind of interesting. So I'm like, huh, I'm gonna Google this author, and turns out that that's a real person's name, probably not our bad guy. But I want to know more about what this stuff means, and it could be useful, it may not be useful, but it gives you something to go on. And this was, embedded as a secondary document within inside your original document. So continuing on with the same document, we're going to do a little bit of dynamic analysis. And so obviously, or not obviously, but you should definitely do this in a virtual machine, not on your production network. And you're going to have to turn off all of your Microsoft Defender to make it work. So just a community service announcement is what this slide's about. So I'm going to use the lazy office Python script. And what this does is there's a couple things, and I can talk about it offline on how to set this up, but you got to have WinDebug installed, you got to have Microsoft Office installed, and you got to have a few other tools installed for this to work. But this Python script basically will interact with your document and attach it to the Windows debugger, and will actually it steps through and debugs the document, and you can get a ton of really great information out of it, as well as interact with the document live and see what it's going to do. So I just tend to just run, you can see here it'll run against Word, Excel, PowerPoint, but it'll also run against VBScript and JavaScript. So you can, if you pull out malicious JavaScript or VBScript, you can also do the same process. So here I'm actually running it against the payment document, and I'm saying it's a Word document. If you look in the red long box, it's Python lazyoffice.py. I'm saying identify this as a Word document. When I say none, I'm saying I don't want you to end on anything. So it's like verbosity mode. It's like just throwing the whole kitchen sink at it and then pointing it at the document I want it to parse. It'll ask you if it wants to create like 15 fake ones to sort of help with any sort of anti-analysis, and I say yes. And as it starts to step through, you can see here that the debugger is starting to identify URLs and files being written in red. Again, we're seeing reference to the temp directory, but it's nothing overly concerning at first. But we're seeing a reference to that same URL that was encoded in that base 64 PowerShell script that we saw. So we're on the right track. And also, while I'm running this on the Windows VM, analysis VM, I've got a few other windows open. So in this case, I'm running Process Hacker. I'm running a tool from the FireEye group, their network monitor. And then I've got the temp directory open because if we remember, RTF documents like to drop into the temp directory. So we'll see if anything's dropped into the temp directory. And so this is just that Python script actually interacting with this malicious Word document. And as it starts to interact and kick off, you can see over on the right, you can see that weird string, that SCT file is actually dumped into our temp directory. We'll see some network traffic on the left, but it's not overly concerning. And then we see a shell pop up with that pdf.exe. So that should be super alarming. Some message box to the user for enabling it to be able to interact. And then if we go back to that temp directory, we see that the malware did some graceful cleanup, right? So it went through and cleaned itself up a little bit. And this is all in the matter of like 30 seconds of runtime. Again, here, if you run fakenet.ng while you're doing this, you might be able to get some useful information. So we go to the user's app data roaming, and we see that it's dropped that pdf.exe file. And then we can continue to go on and do some binary analysis of that. Continuing on with this exact same sample, some stuff that you could do if this document was to be launched on the system and you weren't able to recover it. In this case, because it was a virtual machine, I just snapshotted it real quick and grabbed the VMem. One of the things that I'll look for during the memory analysis in these investigations is, what applications were ran that are associated with malicious documents. And in this case, we see WinWord was kicked off. I'll do a quick net scan to see what's communicating and when word's communicating, which may or may not be bad. It might just be doing some updates. But I want to start using file scan, where I'll grep for any signs of VBS script, and I'm seeing kernel file objects for VBS script for the DLL, but not for any VBS script by itself. So I'm like, well, I remember there was this pdf.exe that was dropped, but I couldn't, maybe you don't have full disk when you go out to do your analysis. Maybe you're unable to pull disk across the wire, or you just don't have enough time on scene to actually get a full disk acquisition, and all you get is memory. But you know from your static analysis that it drops this pdf.exe. Well, I can carve for that using the file scan plugin, and lo and behold, I find reference to it. So here I'm going to dump that particular file object from memory. And this is what I've done here. So I've dumped this pdf.exe file object, and it's the same. You can now go through and do your binary analysis of this executable. And the other thing that I want to look for is, I know that during the static analysis process that I had a long string that referenced this .sct file. So you'll notice that there was nothing referencing in the PS list for this, and there wasn't anything in the file scan for it. So using the Yara scan, I can scan across the entire memory range looking for any references using Yara for this particular SCT file, and I see it referenced to PID 2148, which is explorer.exe. And if we go back to probably the first 15 slides, if you haven't checked out by now, remember talking about how explorer.exe sometimes gets picked on with code injection. So that might be what's happening here, but it's definitely gotten picked on or referenced. And we can see Winword has reference to this particular SCT file as well. So we're starting to be like, yep, all the stuff that we saw in our static analysis is starting to add up, both with our dynamic analysis and now bringing a quick little memory functionality into our analysis workflow as well. We're shoring up all the things that we're seeing. And then here I'm just I'm dumping those two processes that it was associated with, which was Explorer and Winword. So I dumped the entire memory address space, running flare strings against it and grepping for that weird SCT file. And I see references to the app data local temp directory, just like we were seeing in our static analysis. And then continuing on, you can see reference to the pdf.exe, and again, it's being referenced as the same variable as it was in that VBS script. And this is just it doing the exact same thing inside of Winword in its dump process, and we're seeing the exact same references that we were seeing. So again, we realized that, yep, our static analysis was pretty much on par with how it actually interacted with the system. And this is just using the handles to look for any handles that 1864 had for file objects. And we see vbscript.dll. So again, we're thinking, okay, it probably referenced some sort of malicious VB script. So with that was a ton, I'm sure. I think I have all of the references to all of the tools that I use. There might be one or two that I didn't. Feel free to hit me up. I'll definitely get you links to them. And again, like Jessica said, these slides will be available. I know might seem like there was a lot, or maybe I moved a little fast, hopefully not too fast. And then I'll be around for any questions. So 13 minutes over. With that, I'll give it back to Jess.
Hi guys, Aaron, wow, that was incredible. So much useful information. Everybody, I hope you're getting all the CLI tools. I know that I've been trying to drop them as Aaron was going in the Discord. Thanks everyone for joining that. And Aaron, that was just an incredible walkthrough of how to analyze malicious documents and a variety of them using CLI tools. Just fantastic. As I mentioned earlier, we're going to share all of the questions that came in via the GTW with Aaron. We've also posted those in the Discord. Aaron and I will be hopping over there so he can respond to these questions. I also want to remind everyone that we have a slew of fantastic industry lectures, labs, and events throughout the month, including next week. On Monday, we even have a LATAM track with some talks in both Spanish and Portuguese. And thank you to Geraldine and Alexis for giving your talk again in Spanish on Monday. But there will also be English language talks on Monday as well. Tony Nutson's going to be talking about remote mobile acquisition and a whole slew of great content next week as well, bringing us to our wrap up on May 29th. We're going to be having a special wrap up session at noon after the Linux Forensics talk, so make sure you sign up for that. We really hope you enjoyed this session and hope to see you at another session of the Magnet Virtual Summit. Thanks, everyone. Bye.